Hello, and welcome to the inaugural episode of our vehicle architecture series. Today, my close friend and colleague Raul Arredondo and I will delve into the fundamentals of vehicle architecture and discuss its increasing importance. As you can see, I'm thrilled to embark on this exciting journey with you.
I'm also excited
Thank
about
you.
the opportunity and the conversation.
No, absolutely. Thank you for joining me. And having like sort of worked in the automotive industry, I know I've been there in over a decade. You've been there for maybe over a few decades. You are well versed with the vehicle architecture piece and topics. I know for sure. We've discussed this at length. But just to start with some of the basics, I'd really say that like let's boil it down to like, hey, what are the fundamentals? What's essential for the listeners or people or folks in the industry to understand or understand? Yeah.
Yeah, no, and that's I think a great starting point. So the way I like to think about it, especially if people listening to this or seeing this are not familiar, it's really through an analogy. So think about the architecture as the nervous system of the vehicle, right? If you think about how the body works with its own nervous system, you're transferring data, you're transferring energy, you're doing a lot of these things. It's the same concept in a vehicle. You need to transfer energy from one place to another, and you definitely are transferring data. Think about how the engine or the battery pack uh, reacts when you're pressing on the accelerator or on the brakes.
Right, right,
It's through this nervous system.
right. And I really like that analogy that you drew, right? And aside from like a lot of people thinking of it as the rise of electric vehicles, we are also definitely seeing this change or transition towards fewer physical connections because there's a lot of wireless data to be transmitted within a vehicle nowadays with the advancement of the type of vehicles that we have. Uh, I definitely see that this evolution will have sort of impacts on various parts, or at least in the automobile as well as in the industry as well. So, how are you
Yeah.
seeing this? Like, what do you think?
Yeah. So maybe starting with a little bit of history. So 15, 20 years ago, no one was talking about over-the-air updates or vehicle to grid or vehicle to infrastructure communication, right? These, if you think about it, it probably didn't exist anywhere outside of Elon Musk's mind.
Yeah,
And so back then, it was really around optimizing the components that went into that architecture. And that was it. It was as simple as that. But when you
yeah,
start looking at what's happening today and you look at the future of mobility, you start seeing changes in the architecture, sure, as a way to do cost savings, obviously, as a way to spend less energy or reduce the energy consumption of the vehicle. But it's mostly about what we're going to be seeing around case innovation. And a few examples are when you think about the different charging levels, level one, level two, level three, over the air updates, and obviously what I spoke about, vehicle to grid, vehicle to infrastructure. All those things are pushing a change in the architecture.
and yeah, I'd say that a lot of folks don't, or at least question themselves of why this is being emphasized so strongly today. Like, why is there so much interest in vehicle architecture? Why does it need to be separated out from the platform? And this is the very reason that you called out, right? So definitely, I'd say right up that when you talked about it, but there is all of these trends, right? Like you spoke about electrification, sustainability, autonomous vehicles, which is pushing this shift, right? And moreover, there is a lot of play when it comes to, like, say, the electronics, electrical systems, which have become more prominent as ever before. But if we would talking about the past, we would focus on, like, say, components that rather than the architecture itself. So you would talk about, like, say, data parts making their way to sort of the without making significant changes to the architecture. But I see the
Yeah.
shift being significant. Like, at least that's how I see it. But why don't we like take a trip down memory lane, saying that, okay, hey, how did this shift occur? Was it, say, leaps and bounds? Was it gradual? Like, what shaped
Yeah.
this?
Yeah. So, the first 100 years, because that's not the case. But
Yeah,
when you look at maybe the last few decades, it's what we were talking about was 12-volt architectures with a ton of copper wires and little computers all over the vehicle, right?
yeah,
And when you think about it, even the way the architecture was built, the assembly process was pretty straightforward. You have the wire harnesses, you have the sensors, you connect them to computers, and then you have some kind of software that integrates all that stuff so that the communication can occur. It's pretty basic, if you will. And now what you have as part of this architectural changes, you're moving to higher voltages,
hmm,
and there's different benefits for that, but you're also moving to wireless sensors. So
hmm,
then, as you're moving to wireless sensors, not all of them, but some of them, and voltages, then your wiring also has to change. And then because of that, you're essentially moving from a centralized system. And again, going back to the analogy that I spoke about, instead of now your brain controlling everything, now you can move to these modular architectures where maybe your arm can be, behave or do things independently. Sorry, your right arm can do things independently from your left arm. So you're moving to this modules or zones that can operate independently within the vehicle, and where to a large degree the data and the analytics, et cetera, live within these smaller modulars, and then these modules then send the only the pertinent information to the central, computer, right? So it's really basically shifting from central standard component based to now modular, dynamic, less wired
correct,
architectures.
correct. And what they're calling it is the zonal architecture, right? Where you have these different, like you put it as modules, but I take it as like, hey, different zones which are operating independently, but they're sort of interconnected, right? So one depends on the other as well. But then it's not like if something goes wrong, you take the whole system down. So I guess that's what you were referring to, right? And that's what you were trying to sort of sway or
Yeah,
talk,
yeah, and
direct everyone towards. Yeah.
yeah, and just full disclosure, I don't know if the industries has settled on the term,
Hmm.
but it's like you describe it. It's really the concept of you're gonna use modules to manage different
Okay.
vehicle parts, different vehicle systems. And so the idea is that you're able to manage smaller sections or regions locally. And again, I mean, we're talking about the car, but imagine, you have areas of the car. So you're
Hmm.
managing smaller sections locally. And so that is basically, for instance, managing the propulsion system independent from the HVAC, or especially like interior lights managed differently or separately than the headlights. So it's all about having this better control over the different areas, which when you think about it, this is going to enable enhancements in the user experience, because automakers will be able to manage these things more independently, offer a better experience.
Sure. No, absolutely. Exactly. I'd say like there are obviously a lot of with the advent of like this zonal architecture or modular architecture that we talked about, right?
Mhm.
There is
Yeah,
definitely a lot to explore, and there is going from like say the traditional conventional setup of central architecture to now the more emerging piece, which is zonal modular architecture. But from a like I know we've talked about the concepts or the terms, but let's maybe try sort of a high level comparison of these two sort of setups, or specifically like, hey, what's the advantage of one over the other? And I'm not saying that one is definitely better than the other, but like, hey, what's considered more legacy, what's more futuristic? Are there specific areas that are suitable to certain situations or car models or platforms? So I guess discussing these aspects would provide sort of a clearer picture, or at least delve deeper
yeah,
into the applicability and sort of the application and advantages.
yeah. Well, and not surprisingly, the the best architecture is whatever meets the customer needs better. So therefore, the
Mhm.
best architecture really depends on what you're trying to do. So on
Mhm.
one hand, you have this central architecture where everything is coming to the same location where you're controlling things centrally. So then the decisions are more straightforward because you essentially control everything from one single point. On the other side, uh, the vehicles are generating more and more data. So now you get into, is my CPU powerful enough to manage all this stuff? And can I really, really manage all these things?
Definitely.
Because now I need to make faster and faster decisions. On the other side, maybe the other extreme where everything is modular or zonal, you are then making decisions a lot closer to where the data is being generated. So then you can say, well, it's going to be fast. You also don't won't necessarily overwhelm the CPU with a lot of data, but then now you have to spend more resources in how do you integrate all these things, right? Because from the user point of view, you still have to make sure that all the different pieces of the vehicle work for the consumer, right? So,
Yeah.
I mean, all these things are basically, or one of the key things that these things are then also doing is they're creating more complexity for at the supplier side, right? Because now
Mhm.
everything that I spoke about is more about the software and how do you integrate it and all these things. So really, again, the answer to what is the best architecture, it depends. But I think it's important that both automakers and suppliers think about it in terms of configure to order,
Yeah.
defined by the vehicle needs, the supplier capabilities, and what is the expertise of the automaker to integrate all of this.
Right, right. And what we need to, I'd say, consider as well is that architecture makes sense. Which architecture makes sense for different types of vehicles? Is there even a sort of a question of is this region based, including sort of brands, models? Now, if you talk about central architecture, while I'm not in no means sort of undermining any of these technologies, they're more straightforward, right? So, like you said, right, it's the nervous system integrates sort of straightforward to integrate, say, maybe a higher risk because if something fails, then the entire system needs to be taken down. You evaluate everything. You try to pinpoint where the sort of the issue or challenges, right? What went wrong. But in contrast, like say these modular architecture, Zonal is more localized. So it sort of makes recognizing
Right.
failures slightly or at least much more easier, right? The
Yeah.
impact that we see of these, like say, architecture shifts and that significantly varies. We've talked about that, like legacy auto OEMs and tier one suppliers are going to be impacted. But the shift, I'd say, towards more sophisticated software, which you brought up, right, and modular integration may influence some entities as compared to the others. But let's see, like through these transitions, is there an effective way of establishing who will be more impacted versus less impacted? Is that something that plays on in your mind as well, or how are you seeing that?
Yeah. I mean, the one thing that we have to remember is that automakers remain the kings, right? They're the ones that are driving all these changes,
Mm-hmm.
both in the software and also in just the way the architecture is designed. So they're basically leading the game, right? And they're leading that because of their connection with consumers like you and I.
Mm-hmm.
On the supplier side, tier one especially, but in general, they're going through a massive transition because where traditionally or for the traditional architectures, people the supply base was really focused on the hardware, and they basically let the automakers do the software. Now it's not just hardware, right? They also have to worry about the software because it's they're going to have to integrate it. But not only that, also because of what I mentioned, that to enable these modular architectures, you have to have more wireless sensors, etc. That's also changing the nature the uh, of the hardware itself. And then when you go to tier two, now you're talking about, well, I used to have all these copper wire harnesses, and then all these sensors that were connected. Now I have, different sizes of copper wiring and different sensors that are wireless. So all these things are creating changes in the hardware, and obviously the tooling. But again, it's all pushed, or it's all being pulled by the automakers, right? So everyone in the supply chain has to adapt, really.
No, absolutely. I'd say that through this, like obviously a lot of entities, automakers, tier suppliers, different types of suppliers within this are getting impacted, but it's also creating new opportunities, right? So I'd say very informative, Raul. I really enjoyed this first episode with you. Yeah, and I'd say yes, join us to viewers for our next video focusing on how the main drivers behind this and how this impacts different cross sections.
Thank you.